Hello friends, welcome to my channel. In this video I will cover GRADE previous year paper 2016 paper set 03 strength of material, design of machine elements and engineering mechanics part I will cover. Up to question number 25 all are 1 mark question, then 26 to 55 all are 2 marks question. Question 6 is a force F is acting on a bent bar which is clamped at one end as shown in the figure. The correct free body diagram is, you have to find out which is correct free body diagram. So here it's 60 degrees, so here also in 60 degree you take a force, opposite side also same force, they will cancel each other, you will get a couple. So you will get a couple here, it's clockwise and a force in red color I will mention. You will get a couple like this and a force, compressive force like this. So in case of free body diagram you have to remove the support. So you will get at support only I am showing reactive couple. This is clockwise, so reactive, it's anti-clockwise you will get, and this is compressive load F, and compressive load it's acting in angle to vertical, so in both direction you will get reaction. In y direction also you will get reaction, and x direction also you will get reaction. Ry and Rx and M is the couple. So from option here in B, support also available, so B is not the answer, and C, here this Rx not available, so C also not possible. In D, your moment is not available, so D also not possible, only A is your correct answer. The cross sections of two solid bars made of same material as shown in the figure. The square cross section has flexural bending rigidity I1, while the circular cross section has flexural rigidity I2. Both sections have the same cross sectional area. The ratio of I1 by I2 is how much? So square and circle, both square and circle, same material, so E1 equal to E2, it's equal to E. Flexural rigidity is EI, same, and here flexural bending, while cross section has flexural rigidity IE, let this is I1 already given in this question, and I2, then area A1 and A2, area is same, A1 equal to A2. So let the square, one side is A and diameter of circle it's capital D. So area is same, A1 equal to A2, A square equal to pi by 4 D square. We will use our bending formula, sigma B by Y maximum it's equal to M by I, it's equal to E by R. This formula we will use. So I1 by I2, it's, in this question directly they ask I1 by I2, so this formula is not required. Directly moment of inertia formula you can use. For square it's A to the power 4 divided by 12, and for circle it's pi by 64 d to the power 4. So A to the power A square is this one, from equation 1, A square is pi by 4 d square. So here A to the power you can write pi by 4 d square whole square divided by 12 divided by pi by 64 d to the power 4. D for cancel. 16 64 it's 4 pi, then 4 and 12 it's 3. Finally you will get 5 by 3. This is your answer. It's equal to I1 by I2. So C is your answer. The state of stress at a point on an element shown in figure A. The same state of stress are shown in another coordinate system, figure B. The component tau xx, tau yy, tau xy are given by. So we will use more circle here. More circle, sigma axis and tau axis. Here it's P and minus P. So one is P, other side it's minus P. Then draw the circle. No shear stress. So your circle will be like this. In plane theta is at 45 degrees. So in more circle it should at 90 degree. Theta is at 90 degree in more circle. So we know sigma 1 and sigma 2, major principal stress and minus principal stress, both will become 0 at theta equal to 90 degree. Here this point, sigma 1 and sigma 2 both will become 0. And tau xx, tau yy both will become 0. Tau xy is P. So from option B is your answer. Which of the given bearings given below should not subjected to thrust load? So thrust load, deep groove ball bearing, yes, this is correct. Angular contact bearing, this is also correct. Then cylindrical straight roller bearing, no. If it is taper, then we can use single row taper roller bearing, this is correct. So C is your answer. It should not subjected to thrust load. C is your answer. Engineering strain of a mild steel sample is recorded at 0.1%. The true strain is how much? True strain is how much? So engineering strain, it's 0.1. It's in percent. True strain, it's ln 1 plus engineering strain. So ln 1 plus, it's 0.1 divided by 100, 001. So ln 1.001. You will get 0.099%. So from option C is your answer. This is 2-mark question. An inextendable massless string goes over a frictionless pulley. Two weights are 100 Newton and 200 Newton are attached to the two ends of the string. The weights are released from rest and starts moving due to gravity. The tension in the string in Newton is how much? So let it's moving in this direction due to 200 Newton force. So with acceleration A1, 100 Newton force, it will move in this direction. Let its A2, its acceleration is A2. Tension in both cases till same. Here also tension T, but 100 Newton direction is downward. Here 200 Newton direction. Then Newton's law will apply here. F equal to 0. Sorry, F equal to mass into acceleration. For 100 Newton body, force along direction of motion, this is positive. So T minus 100, it's equal to T by, it's W by G, W is 100, W by G into acceleration is A2. This is equation 1. So from here, next T value we will put as equation 1. 100 by G plus into A2 plus 100, it's equal to equation 1. Then for second body, it's moving downward direction, so 200 minus T, 200 minus T, W is 200 by G, weight divided by acceleration due to gravity, its mass into acceleration is A1. Here also T value will get T equal to 200 minus 200 divided by G into A1 is acceleration. This is equation 2. And we know both acceleration are same. A1 equal to A2. We can write it as A also. Both are same. So from equation 1 and 2, we can write 100 by G into A2 plus 100, it's equal to 200 minus 200 divided by G into A1. A1 and A2 both are same. You can write A 100 by G into A plus 200 by G into A, it's equal to 200 minus 100. So take common A, 100 plus 200 divided by G, it's equal to 100. Then A equal to 100 by 300 into G. A equal to G by 3. This is equation 3. We have to calculate tension value. So put equation 3 in equation 1. From equation 3 and 1, our equation 1 is T equal to 100 by G into A2, we can write A plus 100. A value we will write from equation 3, it's G by 3 plus 100. So G cancel. You will get 133.33 Newton. This is T value. This is your answer. T is the tension in the string. It's 133.33 Newton. In ISRO also they are asking this type of question. A circular disc of radius 100 mm and mass 1 kg initially at rest at position A rolls without slipping down a curve path as shown in figure. The speed of B at the disc when it reaches position P. It's initially at A position, it rolls. So both translation kinetic energy and rotational kinetic energy both we have to use. So work energy principle we will use here. Half translation kinetic energy due to translation and kinetic energy due to rotation. It's omega half I omega A square plus potential energy HA plus force into distance. Here no external force, so F is 0. It's equal to translation kinetic energy at point B plus half rotational kinetic energy half I omega B square plus mg HB. HB is 0. Frictional force into distance moves. It's also 0. Frictional force is 0. Then it's from rest. So initially at rest, BA is 0. Omega A also 0. HA is your 30 meter. This is 30 meter. No external force. So this is also 0. BA and omega B both are available. HB it's 0. Then frictional force, this is also 0. So finally what we got? mg into HA, it's equal to half mvb, this is B. At point B, vb square plus half I omega B square. And I, this is for disk moment of inertia. For disk it's mr square by 2. Then your V equal to R omega. Omega is B by R, mass given 1 kg, R is 100 mm, HA is 30 meter. Then ENGG is 30, it's equal to half mass into VB square plus here half I is mr square by 2 into omega square. Omega is V by R, B divided by R, its square, R square cancel, then you will get mass also you can cancel, mass. Then G is 10 given in this question, this one. So 10 into 30 you will get 300. It's BB square by 2. Here it's BB square by 4. BB square by 4. So 1 by 2 plus 1 by 4. So if you solve, finally you will get it's 400. BB is 400 root over it's 20 meter per second. This is your answer. It's 20 meter per second. Fill in the blanks question. Question is a square plate of dimension L into L is subjected to a uniform pressure load P equal to 250 megapascal on its edges as shown in the figure. Assume plane stress condition. The Young's modulus E equal to 200 gigapascal. The deformed shape is square of dimension L minus 2 delta if L equal to 2 meter and delta equal to 0.001 meter. The Poisson's ratio of the plane material is how much? Mu value we have to calculate. Poisson's ratio of the material. We know strain in x direction, it's equal to stress in x direction divided by E minus mu into sigma y, stress in y direction divided by U into mu into sigma z divided by E. Here it's plane stress condition, so this is 0, sigma z is 0. You can write it as sigma x by E minus mu into sigma y by E. Here in this question, both sigma x and sigma y both are compressive. Its value is P pressure given 250 megapascal. So sigma x, strain in x direction, it's, you can write minus, both case it will minus, so minus will take common, minus P by E, sigma x is minus P, then mu into sigma y also P by E. This is strain in x direction. Strain value also given, it's 2 delta both side. Here this side delta, this side also delta. So it's 2 delta. Strain is change in length to original length. So strain in x direction is change in length is minus 2 delta divided by original length is L. So write it equation 1. Then this is equation 2. So from equation 1 and 2 delta by L equal to minus P by E mu into P by E. Delta is minus you can cancel. 2 into delta is 1 divided by 2000 length. Minus already cancel. P by E you can take common, 1 minus mu. Then P and E value put. It's 2 by 2000. Then P is 250 divided by E is 2 into 10 to the power 5. Then 1 minus mu. Mu value we have to calculate. So 10 to the power 5, 10 to the power 3. Here you will get 100. 2 cancel. 0 cancel. then 25 and 10, 5 into 5, 5 into 2, 1 minus mu equal to 4 by 5. 4 by 5 is 0.8. So mu equal to 1 minus 0.8. It's equal to 0.2. Mu equal to 0.2. This is your answer. I think it's fill in the blanks question. Oh, yes. 0.2. This is your. If you want to solve this question in y direction also, you can solve. Strain in y direction you have to calculate. Here in this term and this term. Then you have to equate both. You will get your answer. This is the end of part 1. This is set 3 questions. Strength of material, design and engineering mechanics. Thank you friends. Thank you for watching my video. Thank you.